All right, y'all. Okay, so
you're gonna think like, oh, one. And I need to get up to like that. So this x-axis is both.
you have the cheat sheet I gave you.
What?
You get like. What did you? Oh, see, we're all ready. Yeah, no, not really. Points, but like, it like still and the notes all.
Make sure you have the ones on Algebraic strategy.
Yeah, that's, I should take this.
I thought we were gonna do was about roads. I thought it was just a tweet.
But this was not white. Wait, what do you think this year?
Oh.
No, actually, that's. Yeah.
Ew. Ew. Ew.
Daniel, are you hot?
So they have
Really? Here, look what I have for you. You can use my pregnancy fan, which, as you know, is the only reason that I survived last year.
I remember that.
Yeah.
Like, it'd be like, it is, yeah. But it's already, I just keep it on the charger, you know, just in case. Enjoy. It's on Amazon. I'll email you the link if you want. I should be their spokesperson.
How much is it?
No, it was, I think, like $30. We camp a lot. And so I have like several of those just for like when we're camping.
That's scary. I wanna do it.
Not in Texas. We're not like out in Colorado, you know, there aren't like bears, you know, spiders. All right. How's it going? Y'all doing okay? The end of the drop deadline is tomorrow. You know this? None of us are dropping?
No. Anyway.
Okay, so we are gonna do the last day of limits. And then, okay, that's a great question. Monday, you'll have one more day of notes on the definition of continuity. Then Wednesday, we review. Friday next week, you'll take your test. Okay? All right, but you'll have a whole day to review in class. Okay, let's take a look at your notes for today. Maybe we don't have to do every question if y'all are kind of getting the idea. Okay, there are 4 strategies we're going to go over today. Number 1 is going to be substitution. Number 2 is going to be factor cancel. Number 3 is going to be simplify. And then you have 2 special ones. Okay. Okay. So when you are doing a substitution, that's literally as easy as it sounds. You're going to take what the number is that X is approaching, and you're going to sub it into the equation. Now, the one sort of tricky thing with this is for this homework, I really want you to try to do it without a calculator, only because half of your AP test is no calculator. So let's take a look at number 1. Not too hard here. What is X approaching? Then you're gonna take the 2 and you're just gonna pop it in everywhere that you see an X. So that means that I have a 4 times 2 plus 1 and a 2 times 2 on the bottom. 4 times 2 is plus 1 more on top is 9 over 2 times 2 is 4. Okay, take a look at number 2. What are we plugging in on the next question? X approach 1/2. So I'm going to take my half, plug it in everywhere that I see an X. So I'm going to have 4 times a half squared minus 8 times a half plus 5. How do I square without a calculator 1/2? You remember? Just square the top, square the bottom. Just do the fraction, make sure you do both parts. So 1 squared on top would be what? 1 again. And then on bottom, 2 squared would be 4. Now, for my half of 8, do we know what that is? That would just be 4 plus 5. And then a fourth of 4, if I have this 4 on top and this 4 on bottom, what can we do? Cancel them out, it's just a 1. So I have 1 take away 4 plus 5. 1 minus 4 is -3. Add 5 to that, you would get 2. Questions on that? All right, we have a couple of trigs. The reason we're working these into your notes is because we have a test next week and you'll have to know how to do trig without a unit circle. So taking a look at number 3, what is X approaching? What number? Pi over 4 plugs in right here, so I want the cosine of pi over 4. Okay, let's review on your hand. Pinky is what angle? 0, pi 6, pi 4, fold it down. Where are your cosine fingers? Above or below? Sin goes down. Get it? Okay, so your bottom fingers, you're going down, you're sitting, okay? And then cosine, you're going up to heaven, I don't know. Okay, so for cosine, how many on top? So it's root fingers over 2, so it'd be root 2 over 2. Take a look at number 4. What's X approaching? Pi over 6 plugs in where the X is. So I have the sine of 2 pi over 6. Now for fractions, okay, you just times the tops and the bottoms together. Does 2 have anything on bottom? It's really just a 1, right? So I have 2 pi over 1 times 6 would be 6. What would 2 pi over 6 reduce to? Pi over 3, very good. Okay. So we times the parentheses together because we're following PEMDAS. Okay, and then once we reduce this, we get pi thirds. Which finger is your pi thirds finger? So 0, pi 6, pi fourths, pi thirds, fold it down. And where are your sin fingers? 3, root 3 over 2. Okay, now remember that it's always over 2 and there's always a square root, but sometimes you can reduce it to a whole number. Okay, go to the next one. How many X's are in number 5? Okay, there's an X in the front and there's a cosecant X. So we need to make sure to take that number and plug it into both spots. So I'm going to have pi thirds times CSC pi thirds. Now, I know when we did your hand trig that it was a lot all in the same day. Okay, but cosecant is one of your originals flipped. Do we remember which one? Sine flipped. Very good. So I'm going to put that here. That's going to be the sine flipped. So find your pi thirds finger. We actually already knew which one it was from this example. Pi thirds is this one. My sine fingers are below, which means I have how many? Root 3 over 2, but I'm going to flip it. So what is it now? 2 over root 3 times the fraction in the front was pi thirds. Now remember what I said. If you're multiplying fractions, you're going straight across the top, straight across the bottom. So 2 and pi makes 2 pi on top. And then 3 times √3 is 3√3. Okay, remember for delta math, I think you had to fix this. But for the test, you will not have to because AP doesn't care about that. All right, you're done with substitution. Any questions? All right, turn the page. And then your blank at the top, if you're someone who likes to fill in all the blanks, is without a calculator. All right, the next section is called factor cancel. Now, on your very, I think, second day in class, maybe not first, we did a little review and we covered 4 different ways to factor. I'm going to remind you of what they are. We learned perfect squares. We did GCF. Oh, it's Rosen, sorry. We did trinomials. And then we did grouping. Okay, those are your 4 ways to factor. All of them will come up in our examples. Okay, so once you've written those down, take a look at number 1. If I were to plug in a 0 right now, because x is approaching 0. If I were to plug that in right now, what would I get on the top as my final answer? Look at it for a second. Good, it's gonna be 0 squared minus 3 times 0. Everything zeroes out, yeah? Okay, then look at the bottom. I had a 2x. So if I do 2 times 0, I'm gonna get, again, 0. Anytime that you get 0 over 0, that means that your limit is fixable and you have to do more. Look at that, okay? You have to do more to get to the answer, okay? And what you're gonna do is factor cancel. So taking a look at that same example, we got 0 over 0, which means we need to do more. How can I factor the top? X out of the parentheses, which type would that be here? GCF, very good. So I'm going to take the X out. That leaves me with an X minus 3. And then on the bottom, I had a 2X. Okay, once I factor an X out to the front, what can I do with the X on top and the X on bottom? Cancel them. Remember, the name of it's factor cancel, right? So our whole goal is to try to cancel out that X so that I can go back and substitute, which is our first method. So now that these are gone, what was my limit as X approaches? 0, then I just want to plug in 0 now if I can. So on top, what is 0 minus 3? -3. And then on bottom, I just have a 2. So it'd just be 2. Final answer, -3 over 2. Questions on that? All right, go down to number 3 for me, please. We'll skip around a little bit here. Number 3, X is approaching 2. I'll save you a little bit of time that if you were to plug 2 in, what do you think you would get on top and on bottom? Okay, it is going to come out to be 0 on top. 2 minus 2 on bottom would also give you 0. And anytime you hit 0 over 0, it's not DNE. That means it's fixable. You just have to, yeah, that's right. You got to do more. Okay, so take a look at your top. It's x cubed minus 4x. Can I take an x out just like last time? Yes, so let's do that first. X comes to the front. Out of my x cubed, now it's an x squared, yeah? And then my minus 4x is now just a minus 4. Okay, on the bottom, I only had an x minus 2 to begin with, so I'm just going to keep it the same. Okay, is anything going to cross out yet? So far? Oh, can't cross out the x's because this x is alone and this one's with a minus 2. So what next type of factoring could I do? Perfect squares. Remember that this can break down. What's the square root of x squared? It goes down to just an x. And what's the square root of 4? Plus or minus 2. Do you remember? So it's going to be like this. X in the front, x plus 2, x minus 2. And then on the bottom, I have an x minus 2 as well. Now, as soon as you break down your perfect squares, now I see that something is going to cancel. What will it be? The minus 2's. And as soon as you fix the 0 that keeps popping up on the bottom, now I can apply what x was trying to approach from the beginning. What was my number my limit was going to? 2. Then now I can plug in a 2. But these terms are gone, so I'm only plugging it in onto the top. So I'd have 2 times parentheses 2 plus 2. Remember PEMDAS, 2 plus 2 in the parentheses is 4, multiplied by 2, we get 8. Can you do it? All right. Let's go down to number 4. Okay, x is approaching 0. Okay, now we took this for granted on the other examples, but if I plug in x approaching 0, go ahead and do it on your paper. Remember, x is approaching 0, not a. So any of your x's are going to swap out for zeros. So on top, I'd have 2 times 0 minus 2a. And I'd have 0 squared minus a squared. What's 2 times 0? Minus 2a is just minus 2a. On the bottom, 0 squared minus a squared would give me minus a squared. And so this isn't coming out to 0 over 0. I don't have to do more. Okay, I just am going to find my answer. Now I can simplify this. A negative top and bottom is going to do what? How will that come out? Positive. And then if I have an a on top and an a squared on bottom, how many a's are going to stay in my answer? Only one. Where? Top or bottom? Bottom. So it'll be a 2 over a for your answer. Okay, and if you think about why, your a squared is really a times a. Knock one of them off on top with one of them off on bottom. Okay, now number 5 should have been written differently. Should be x approach a. So if you'll change that 0 here to an a. Now think about what would happen if my x turns into an a in the equation. What am I going to get on top? 2a minus 2a, which is 0. What am I going to get on bottom? A squared minus a squared is also 0. And any time that you get 0 over 0, you have to do more. Okay, so looking at your fraction, think about how you could factor the top. We've already covered it so far. Which of the 4 methods? Do they have anything in common? 2, yes, that's right. So I'm going to take a 2 out of the top. What's that going to leave me with if it was a 2x minus a 2a? X minus a, very good. Okay, so I'm taking the 2 out of this version. Remember, we tried this and we got 0 over 0, so we're going back to the original. So I took my 2 out, I have an x minus a. On the bottom, I can perfect squares that. What's the square root of x squared? X. What about a squared would go to an a, but 1 gets a plus, 1 gets a minus. So it'll be x plus a and x minus a. From there, will anything cross out? Yes, what will cross out? The x minus a's. And as soon as that crosses out, remember you're trying to substitute. So go back to the first method. My x was trying to approach a all along. So now let's see if we can plug that limit in. On top, I'm just going to get a 2, sorry. And on bottom, I'm going to have an a plus a. How much is a plus a? 2n. And then from there, what can happen? So is my answer just a? 1 over a. Okay, remember, you cannot leave nothing on top. So as soon as you cross that 2 out, you need to leave a 1 as a placeholder in that position. Okay, so as soon as my 2 is gone, I have to leave a 1 up there as a placeholder. Does that make sense? Okay, for number 6 and 7, change one of them to a regular 2. Let's change the first one. Okay, and then you'll notice the fraction-y part though is the same. So can you factor the top? Do you remember how to do that? Okay, so will you do that, please? So we're gonna break our fraction down into parentheses. That's the goal here. So it's x squared plus 9x plus 14. So I think when I showed y'all how to do it, I used an x. Okay, but whatever other method you know is fine. So it's A, B, C. If you want to do it my way, you're doing AC multiplied together. 1 times 14 is 14, and then I list my factors. What will multiply to 14? I could do 1 times 14 or 2 times 7. But remember, those numbers need to also add to B, whatever your B is. In this case, my B is a 9. So which of those will add to B 9? 2 and 7. So it'll be x plus 2, x plus 7. On the bottom, what type of factoring can I do? Perfect squares. So it'll be an x plus the square root of 4 is 2, and an x minus 2. From here, what's going to cross out? Okay, the plus 2's are going to cross out, which means that my final equation is x plus 7 over x minus 2. Okay, now we're going to take our limits and we're going to try to plug those in. For the first one, what did we change it to x approaching? Positive 2. And then for the second one, we're doing x approach negative 2. Okay, let's do positive 2 first. What am I going to get on top? 2 plus 7 would be 9. What am I going to get on bottom? 2 minus 2 is 0. Okay, so in this case, I did all that work to factor cancel, but I still got to divide by 0. Is it a do more where it's 0 and 0? Then this is an answer. If it's a number over 0, that means it's DNE. Okay, the only time you need to do more is if it's 0 over 0. If you get a 0 only on the bottom, that's because that limit does not exist. Take a look at number 7. If x is approaching negative 2, all the crap is the same. It would still come out to this. X plus 7 and x minus 2. When I take my negative 2 and I plug it in here, do I get an answer? What's negative 2 plus 7 on top? 5. What's negative 2 minus 2 more on bottom? Negative 4. Very good. Okay, but if you had not factor canceled this one would have come out to 0 over 0. So if the limit is fixed, you can still get an answer. But if you're still getting 0, it's D&E. Let's review why that happens. You learned this in pre-calc. Okay, anything in the denominator that cancels out creates a hole in the graph. And if you have a hole in the graph, that's also called a removable asymptote, or sorry, a removable discontinuity. Okay, if you have a hole in the graph, both sides are approaching the same value, so your limit is fixed and still exists. Because even if there's a hole in the graph, we don't care about the hole, we're just tracing towards on both sides. They're going towards the same open circle. Okay, however, in pre-calc, Do you remember what happened if you had something on the bottom and it did not cross out? Remember what happened there? It was either a whole or an asymptote. Very good. So if it's in the denominator, but you didn't fix it, it didn't cancel out, it's going to create a vertical asymptote. And if you're looking at a vertical asymptote, the limit is going to not exist. Okay. So the way that I would think about it if I were you is just think about if I can fix it, it's a hole and the limit still exists. If I can't fix it, there's an asymptote, which means the limit's at the end. Make sense? Okay, go ahead and turn the page for me. Okay, we have 4 more, and then we're gonna take a break and do your delta math for a little bit, okay? Number 7. You'll notice that you have a 4x squared in the front. Do you remember how to factor like that? Or should we do it? Huh? Uh-huh. You multiply the A and the C. So if I'm doing number 7, what is my A and my C? Okay, what is 4 times 4? So that would give me 16 at the top. And then what's my B that they need to add back to? 17. Let's list our factors as 16. I could do 1 times or 2 times 8 or 4 times 4. But then out of all those partners, which of those is going to add back to 17? Okay, good. This is correct. But your factors are not x plus 1 and x plus 16 because of this 4. So at this point, you have 2 choices. You can factor by grouping, or you can, did I show you all divide and slide? Okay, if you forgot, let's do grouping, because maybe you remember that since you did it in pre-calc. So it'd be 4x squared. And then the numbers that I'm picking are a plus 1x and a 16x. Plus 4. Now, I want you to think about, are the same plus 17x's still here? Because I have a 1 and a 16. Together, that's all my same x's. I'm just splitting them into groups. This is called grouping. So you're going to underline the first 2. Look for the GCF. Underline the second 2. Look for the GCF. What can I take out of the first 2 partners? An x is correct. Very good. What will be left behind in parentheses when I pull the x out? Say that again. That would be fine. The order doesn't matter. So my x comes out. I'd have a 4x plus 1. Are we good with that? Okay, out of my second partners, what can I take out? A 4. And when I take my 4 out, my 16x is now a 4x, and my plus 4 is now a plus 1. Does this look familiar? You did this? Okay. Then from there, one of your parentheses is supposed to match, and I see that they do. So it'll be 4x plus 1. And the other one is x plus 4 that you pull from the outside. Okay, so it'll look like that. Okay, so it's a little bit more work than divide and slide, but hopefully you'd always remember it, maybe compared to a trick. Okay, what was on the bottom of our fraction? Okay, will anything cross out? X plus 4s are gone. And remember, the whole point of me getting rid of those is that now I can try my limit again. What is x approaching? What number? -4. And now if I plug in a -4, I'm not going to end up with -4 plus 4 on the bottom, which gives me the divide by 0. So I fixed it. Okay. What is -4 times 4? Okay, -16. And then I'm going to add 1 to that, which is -15. Okay. Do you think you could try the next 3? Yes, you can finish out this page. And I'll come around and help you if you need it. Okay, but hint, one of them is not fixable. But you'll never know which one until you try. No, you already guessed. Okay, try the next three. You have 4 ways to factor. You've seen all of them. The next three, one of them's a GME. Oh, you're finished? Just put it on the board. Yes, sure. Oh, she was saying it's faster. You will. Okay, 1 and 8, what else? 2 and 4, and we're trying to add to get to the negatives of that possible. Which ones are gonna add to 2? You can't subtract, you have to add. Can you do it?
Wait, so are we trying to get negative 2 or just 2?
You can try to get negative 2, but they have to add to get that. Is it possible? That's the one that's not. Because this would have to have a minus at the top for you to be able to do like 2 minus 4, because you got numbers, and you're not allowed to subtract because you're 8 stuff like that. Yeah, that's right. And remember, what that means is that the graph, you have a whole or an asymptote, so it fix it. Asymptote and add an asymptote limits, and it is this or taking. Versus if you can fix it, it was a whole and the limit says. And now, do you remember how fun it was? Find all the holes now.
That was probably one of my favorite. Like at first it was hard because like you know stage to remember like oh which one is the bottom.
Yeah.
Were you here for that one?
Yeah, that was in the fall.
Yeah.
When I left with all the shining just. And y'all were doing like all the. And then when there was that problem about like, my wheels is swinging on a road.
I feel like
You're trying to make a sign function that will model.
and then the person that had it, those who were taking like they were not very like they were very
That was rough. This one you actually can't factor. Here's why. What's gonna happen when you use negative 4 times 2? It's gonna come out to be a plus 8. So you actually, it's kind of a trick. You can't factor that. You get close, but then in order to get this negative 2, that would have to be a minus 8. That's not coming. It's gonna be
Yeah, so like.
you come up to the top. So underline your first 2 in your second.
Anyway.
And then see if you can take out a GPF and get your parentheses and then go through. Okay.
Where you were talking about the side, that can't be.
Oh, okay. I'll explain that to you. See if you can do, I don't think that comes back up for the rest of the class. You do need to know how to do it with your test. All right, how are we doing? Oh, wow.
Annie.
I think, no, I think this one comes up to your. Because,
I got it, but then.
you just.
Okay, then maybe.
Why did you feel about
Then maybe she will talk about one. I don't want to write.
you only have to vote?
You said you did. I know, but I never read it. Oh, so you got it.
So for ABC, it doesn't.
That's a hundred and that's.
That's only if it's.
Whoa. I know, if I don't know.
You're trying to get to 2, you need to know 1 and 1 to make that. The negative 1 plus 1 is equal to 0. Good job. Yes.
So by the way.
Yeah, so if you plug in the numbers, you're gonna get 0 on mine. And remember, that doesn't mean do more. Not like you go anyways, when you factor here.
Yeah.
So that. And then remember, if it's not fixable, you can vertical has to go. Or no, this one was fixable. And eliminate this.
But I wouldn't, but you do that. What you kind of.
Okay, so for this one,
That's all I was looking at. I'm like, why did you put it in that one?
so you're gonna.
We make the 8 negative.
The first one together, the last one You can think about it, 0 divided by anything, so 0, and that's a number. That counts as the answer. Just like on this one, you got 0, and it was on the top, then 0. It's just no divide 0. Do you want that? Or I can. Oh, you know, okay. This. The third one, you can take whatever the numbers. The problem is. Yeah, I think does that make sense? But if you can plug it in and get an answer right off the bat, that's a good
Well,
one.
I got a little bit of it, and I can't see that.
Okay.
I thought we were first gonna talk about that. There was things being real years ago.
And then, okay, but either way.
I
Now,
thought we were just gonna do this on here.
this one, you can't cross out. You can only do like one for one, one off the target. Okay. So then you do negative one. Negative. Negative, yeah. You cross that. You do one. Negative 1 plus 5. 0 times 1. It's not a 0 on the bottom, it's all the stuff on the bottom. Did you get it? Yes, what, ask me what? You don't. Because anyway, you can divide a one out of it, anything.
No.
Wow, good job, good job. And then from there, your -2 is crossed out, you plugged in -2 squared as well.
Yeah, definitely it's not like they make.
Okay, if you were able to get all of them, you can do the first half of your delta map. Yeah. Yeah. Oh, you can. It has to be multiplied for you to cross out something on the bottom. You can't have like, think about it with like fractions. If you had this, let's say I had 1 plus 3 and then divided by 3. If I just cross these out, what am I saying the answer is? 1. But if I do real math, what's 1 plus 3? 4/3. Are 4/3 and 1 the same? Ah. So that's how come it has to be multiplied for you to cancel stuff out. You know what I mean? Has to be real math. Okay. You need help with that? Oh, like -1 plus 1. And 0 times that. And remember, 0 is a number. That counts as an answer. Where can you not have a 0? At all. So if you end up with a 0 on the top, that's fine. Then your answer is. You should have gotten DME for number 8, and then 5, and then 0. You should have it first. And then X minus. Okay, out of your X minus.
Yeah, but we did that. Yeah, she said she could, you need to have.
Did I help?
Everybody. Go.
And then you look for stuff.
Wait. Oh my God.
Yes, let me pause this from recording. Okay, so in the simplify section, okay, you're gonna be trying to make a way to fix the equation, not necessarily using factor cancel, but your goal is to plug this number in. If you can already plug it in, you don't have to fix anything. Okay, but if you can't plug in 9, like say on this one, why can't I? Well, if I do √9 plugged in minus 3, what do I get on top? And what about 9 minus 9 on bottom? 0. Then that's a do more, but I can't factor square root x minus 3. That's not a thing. So in this case, you're going to use what's called a conjugate. Okay, so rewrite your limit bigger if you think you need to. And what a conjugate is, you should have done these in square roots and also in complex numbers, is you're going to take whatever the middle sign is and just flip-flop it. So for example, on top, I have a √x minus 3. If I want the conjugate of that, I'm going to do √x plus 3. And I'm just going to switch that middle sign. That makes it a conjugate. Now, you should have learned, though, that you can't just times something on top. You have to also times it where? On bottom. So I'm going to have another √x plus 3 on bottom. Okay, now my fraction is a little bit bigger, okay, but it's going to fix the problem because the tops of these being conjugates is going to make a difference when I times it out. Let's do it one term at a time. Okay, and again, these are called conjugates. Okay, the pattern that we're about to do pretty much always happens if they're conjugates. So let's FOIL it out. What is √x times √x again? It's regular x. Very good. Okay, the reason why is √x times √x is √x squared, and then the squared and the square root cross out. Next term, I want √x times 3. Well, then that would just be plus 3 square root x. Next term I'm going to times is the minus 3. What's minus 3 times √x? Minus 3 √x. And then last term is minus 3 times minus 3 again. What's that? 9. Okay, good. Now, before I go on, look at your top 2 terms. What's going to happen in the middle? You have a plus 3 √x and a minus 3 √x that are going to cross out. Anytime you have conjugates, those middle terms are gone, and I just have what on top now? X minus 9 over, that looks familiar, another x minus 9, and then a √x plus 3. Okay? Now, you might be wondering, well, why did I take the time to multiply out the top but not the bottom? Don't multiply out the bottom because they're not conjugates. You're just going to get a worse looking, complicated thing. Just leave the bottom because they're not partners. Okay, then from there, I can retry my limit as x approaches 9 after I cross these guys out. Do I have to leave anything on top? You have to leave something. What can I leave on top? A 1. So my final answer is going to be 1 over √9 plus 3. But what is √9? 3 plus 3, which means my bottom comes out to a what? 1 over 6. Very good. Okay, take a look at number 2 when you're ready. We'll do one more of those. Okay, you're never gonna conjugate just like x minus 5. It's always gonna have something weird in it, like a square root or an I or something like that. So for number 2, which part should I do the conjugate for, top or bottom? Bottom. So I'm gonna do root x plus root 5 on top and a root x plus root 5 on bottom. Okay, but remember, the reason I'm using the conjugate is because if I plugged in 5, I would have gotten 0 over 0. I'm skipping that for this one, but it's happened enough that we know that's what happens in this one. Will I multiply out the top by FOIL? No, they're not conjugates with each other. So if I do it, it's kind of a waste of time. Leave the top alone. But then when I get to the bottom, I notice that those are conjugates with each other. What is root x times another root x? Regular x, very good. What is root x times root 5? It would be root 5 root x. Okay, then I move to my minus 5. What's minus 5 times root x? Minus root 5 root x. And then for the last one, it's negative root 5 times another root 5 is what? Negative 5. Very good. Okay, but every time those middle two should be crossing out with each other. The outside and the inside give you opposites because they were conjugates. So now these guys are gone. What's really on the bottom? An x minus 5. And where else is that term? On the top. So once you eliminate that term, now I can retry my limit as x approaches 5. So if I were to take my limit as x approaches 5, now I have root 5 plus root 5. Do I get root 10? No, what do I get? What's root 5 plus root 5? 2 root 5. Okay. All right, do we feel like we can do that? Maybe? Okay. We're gonna come back to 3 and 4 next time. There are not any like that on your homework, so turn the page. Sure. Okay, on the last page, there are 2 special limits that I'm just gonna have you write them down, and then we'll do a couple examples to make sure you know how to use them. Good? All right. So at the top of the next page, there's only 2 specials. Okay, and I think actually in first period, I only did rule number 1, so we'll do the same. We'll just do rule number 1. Anytime that you have a limit as x goes to 0 of sine ax over bx, your limit's going to come out to a over b. Okay, this is a very easy rule that you can just remember. So look at number 1. Is x going to 0? And it's sine 15x over 10x. Then I'm going to 15 over 10 as my answer. Will delta math count that as correct the way it's written? It can be reduced. Divide both by what? 5. So 15 divided by 5 is a 3. 10 divided by 5 is a 2. Okay, take a look at number 2. I have a sine x over 6x. What number's in front of the sine x? That's a 1x. And if my x is going to 0, this is my special limit. My answer is 1 over 6. Okay? You said you lost? Okay. Okay. Keep thinking about it. Rule number 2 is not on your homework. We are going to cover it next time. But for now, finish up your delta math. You guys still have about 20 minutes, and we'll catch the rest of this next time. Okay, Michelle, you put your number. So it's just like a rule that like you don't know why it is.
Okay.
So if you get a limit as x goes to 0 of a sine x over another x, you're gonna just kind of think of it like a bed. Like you're dividing the numbers.
Just dividing the cost.
Yeah, so it's just 15/10, or on this one, there wasn't a 1 there, but we know if it's an x alone, it's a 1x. So it's almost like a bed. Okay? You're welcome.
I just finished my homework last night.
Okay.
Thank you. And I think Rebecca did too. Rebecca.